Okay, so now we are going to look at loops and timing delay modules. We're just going to see how loops are working. For this purpose, we are taking a very simple program to start with. Suppose there is a program which starts with memory location 2000. I give a simple instruction MVIC 03H. What this instruction is going to do is, it is just simply going to load C with 03 with contents 03. Now since this is a 2-byte instruction, next instruction is going to begin from 2002. Here I am giving a simple instruction DCRC. Then I am giving a jump instruction, a conditional jump JNZ 2002. If the okay, first let us write the program. This is a 1-byte instruction, so address for this instruction is going to be 2003. This is a 3-byte instruction, so next instruction is going to come at 2006. There I am giving halt. Now what happens in this program is, we are loading C with 03, then we are decreasing C. Suppose in this cycle C becomes 02. Then we are going to check C, the contents of C. If contents of C are 0, the program is not going to jump. It's going to jump. If jump no 0, see J and Z means jump not 0. If not 0, jump to 2002. If 0, then the condition is false, there will be no jump, the program will end. So I am just trying to represent this. First instruction is MVIC 03. Then we are making DCRC. Then we are checking jump no 0, jump not 0, 2002. So here we are going to check the 0 flags. We are going to check the 0 flag. If not 0 means if Z flag, 0 flag is 0, not 0 means Z flag is 0. Jump to 2002, 2002 means jump to 2002, DCRC. If 0 flag is 1, that is if the condition is not true, if the condition is false, program is going to stop. See, this jumping, again decreasing C, again checking the condition. This is the loop. This is known as looping. This is the loop. So now we are just going to see how many times is this loop going to run. See, first time what happens? We are loading C with 3. Then we are decreasing C. So value of C, contents of C become 2. Now we are checking the condition. We are checking the 0 flag. Obviously 0 flag is not 1 because contents of C are 2. So again you reach here. This is the first loop. What happens in first loop? C is 02. Condition was false. So we had the first loop. Now what happens? Now again you are decreasing C. Now C has become 01. You check the condition. Condition is false. You've got the false condition false. This is the second loop. Second time that the loop is executed. Now what happens when again you reach here? Again you have reached here. In the third loop, third time when this happens. Now C is 00. Now you check the condition. Now the condition is true. Condition true means you will get out of the loop. Program will stop, halt. Program will stop. So total number of times that the loop was executed is 3. 2 times number of times loop is executed is 3. Now number of times when the condition was false condition. Okay, sorry, see, according to this program, this is true condition. True condition means the program was not 0. So I can I write it as condition true. condition true. This is true, right? This was not 0, so therefore we made the jump, condition true. Okay, just make a correction. This is condition true and this one is condition false. Condition false means now this was 0, so we exited the program. So true condition, for true condition we executed the loop 2 times and 1 times we executed the loop for false condition. False condition we executed 1 time. Total 3 times the loop was being executed, 2 for true condition and 1 for false condition. See, this is a kind of, if you have any idea of C language, there are 2 types of loops that we are studying there, do while and while. What happens in do while is first you perform the task, then you check the condition, and what happens in while loop is first you check the condition, then you perform the task. So the idea that we are using here is a do while. This is a do while loop. Do while means first we are performing the task, then we are checking the condition, at the end we are checking the condition. Now again, just see the timing of the loop, just see in one loop. This DCRC is a 4 T states long instruction. DCRC has only one machine cycle, opcode fetch. This JNZ 2002, this is going to take up 10 T states if the condition is true, or 7 T states in case the condition is false. So what happens in one loop? One loop of true condition is going to take up 14 T states. 14 T states. This is also going to take up 14 T states. And one loop of false condition is going to take up 11 T states. 11 T states. So this module, this looping module is going to give you a total delay of total time. This is going to take total time of 14 plus 14 plus 11, which is 39 T states. 39 T states. If you also include the time of this instruction halt, which takes 5 T states, MVIC03H, which takes 7 T states, we can just find the total program of the time. See, we have taken a very small example here. We just loaded C with 3. Therefore, 3 times this loop was executed. But we can use this concept. We are going to use this concept to produce a delay of 50 milliseconds, sometimes 100 milliseconds. Next, we are just going to look at an example that how can you produce a delay of desired time period. Suppose you are required a time delay of 50 milliseconds. We can produce a delay using this kind of program. So for now you can just understand that this is the concept of looping. By taking help of conditional jump, we can produce a loop and we can produce a timing delay module. This is how you produce a delay in a program. So now we are going to look at timing delay modules. For this purpose, we are having a basic module that we are going to use according to our desire. Whatever timing delay, whatever delay you are wanting, you can use that module accordingly. Just have a look. We are using a basic program. Suppose MVIC, 00. What does this instruction do? This just loads C with 00. Next I am having DCRC, and then suppose I am giving this a label. This is just a label because we do not know, we are not confirmed for the address of this instruction, so I am just giving it a label x0. Next instruction I am giving is jump not 0 x0. Now what is actually happening in this program is we have loaded C with 00, we are decreasing C, we are decreasing the contents of C, and until and unless the contents of C again become 00, this loop is going to take place. Now you know that from 00 to again 00 we are going to have 256 values, 256 number, since these are in hexadecimal, right? So what is happening is this loop is going to be executed. 256 times, of which 255 times the condition is going to be true, and one time the loop is going to be executed for false condition. Now I am trying to just calculate the T states of this for this program. Total time of the program is going to be, firstly I'm just calculating the loop time, okay, then we can just include this instruction also. So total time is going to be 255 into time for true condition. Time for true condition, see this instruction is 40 states long. If the condition is true, this conditional jump is going to take 10 states. So it becomes 40 plus 10t plus 1 into again this DCRC is going to take place, so 40 plus this is going to take 70, okay. And one more instruction we can see here is MVIC, 00, which is a 7t states long instruction, So this is the total time of this program, total time required for this module, which if you calculate these, if you just calculate this, it comes out to be a total of this is going to be 3588t. Also all of you are aware that frequency of 8085 is 3 megahertz. So this t is going to be 1/3 microseconds, which makes this a total of 1.196 milliseconds. Okay, if you just put t, I am just putting t as 1/3 microseconds, okay, and I have made the calculation. You can also try, you just find that this timing module, this module is going to be 1.196 milliseconds. Okay, one more thing that you can note here is, since I have loaded C with 00, this instruction is going to take 256 loops to come here. In case I had loaded this with FF, if I had loaded this with FF, this would have taken 255 loops, 255 times the loops would have executed total. Okay, that is another thing. So finally what we have got is, this module can give us a delay of, provide us a delay of 1.196 milliseconds. Now our concern is, suppose you are given, you are supposed to write an ALP. You are supposed to write an ALP to produce a delay of 50 milliseconds. So what you are going to do is, we are going to use the concept of nested loops. What is nested loops? We are going to use this loop several times such that we can produce a total delay of 50 milliseconds. Now see, this module can produce a delay of delay module available. We've just calculated this can produce a delay of 1.196 milliseconds. Now required delay. Suppose you require a delay of 50 milliseconds. Now the question is, how many times should I run this module so that I can get a delay of 50 milliseconds? So what do I do? Number of times module should be executed. How do I do this? This is going to be 50 divided by 1.196. When you perform this calculation, you are going to get approximately 41.8. 41.8 I am taking as 42. That means for getting an approximate delay of 50 milliseconds, I should execute this module for a total number of 42 times. When you represent 42 in hexadecimal, if you just try and represent 42 in hexadecimal, then you are going to get it as 2A. Okay, where should I write this? I am writing it here only. This is going to be 2A in hexadecimal. So now what am I going to do is, I am going to use another register, any register, maybe B. I'll load B with 2A and I'll execute this loop inside a different loop. See, just look at the program now. Just look at the program. What am I going to do? I am loading B with 2A, MVI B, 2A. The basic, the concept is same. What do I do? DCR B, and after that I load MVI B with 2A. Then I am going to write this module. Just write the module MVI C, 00, DCR C, jump not 0, X naught. This is X naught. Then what do I do? DCR B DC are B, and jump not 0 Y. This I am making as Y. So this is known as, and then halt, okay, of course, halt. This is known as nesting of loops. A loop is going to run, this loop is going to run inside another loop. Okay, this is a loop inside another loop. This is known as nesting of loops. So this program is going to run for 42 times, right? Since you have loaded B with 2A, so every time B will get decremented and you are going to check it for 0. So this module is going to run 42 times and it will produce a total delay of 50 milliseconds. See, I am not considering T states for these instructions, because already the T states for these instructions are negligible in consideration to total number of T states. Already this had 1.196 millisecond, it is producing delay. Combinedly also these are going to be some 7 to 10 T states, which is not going to make a lot of difference. So you can just focus on this timing module, which is producing 1.196 milliseconds, and just see how many times this needs to be run to produce a total delay of 50 milliseconds. So this is the program. You yourself, for your practice, you can try to write a program which can produce a delay of 100 milliseconds. I am just giving the solution here. You can write it by yourself and just check and verify. So if you try to produce a delay of 100 milliseconds, this is just going to become 5/4. Rest everything will remain same. This is how you can produce a delay of 100 milliseconds. So this is all about loops and timing delay modules.